Hello everyone. So today we'll be beginning with topological dynamical system, and this is the very first lecture in this series. Okay. So सबसे पहले हम देखते हैं कि topological dynamical system क्या होता है. So a pair XF where X is a topological space and F is a map which is a self map. इसे हम बोलते हैं self map. Why? Because it goes from x to x, which is continuous. So this pair is said to be topological dynamical system. ठीक है, एक ऐसा पेयर जिसमें पहला एक टोपोलॉजिकल स्पेस हो और दूसरा f एक सेल्फ मैप हो, उसे हम टोपोलॉजिकल डायनामिकल सिस्टम कहते हैं. ठीक है, इट इज अकिन और सिमिलर टू योर टोपोलॉजिकल स्पेस जिसमें हम एक सेट लेते थे, ठीक है, एसोसिएटेड विद टोपोलॉजी. यहाँ पे वो पेयर है एक्स एफ. ठीक है, वेयर एक्स इज अ टोपोलॉजिकल स्पेस एंड एफ इज सिंपली अ सेल्फ मैप. ओके, अब मैं दो डेफिनेशंस डिफाइन करती हूँ. ठीक है, सो देर आर बेसिकली टू डेफिनेशंस. सो फर्स्ट इज द डेफिनेशन ऑफ फिक्स्ड पॉइंट. ओके, and second is a definition of periodic point of prime period n. So these are the two definitions which we will have a look at. Okay, so first of all, what is a fixed point? So see, you have a map here which is a self map, a continuous map from x to x. Okay, so a point x in capital X such that f of x is equal to x is called fixed point. ये तो हमें पता ही है, हमने बहुत बार पढ़ा है. ये एक ऐसा पॉइंट जो कि खुद पे ही मैप हो जाए अंडर द मैप, उसे हम बोलते हैं एक फिक्स पॉइंट. द सेट ऑफ all such points, the set of all such points x in capital X जिनके लिए f of x x के बराबर हो जाए is called as the fixed f. Okay, the fixed point set. Similarly, a point x in capital X is said to be a periodic point of prime period n. Okay, such that it is a fixed point of fn. ठीक है, यहाँ पे मैं बता दूं fn क्या है. इट इज द composition of f n number of times. Okay, but या एंड मतलब जो पीरियोडिक पॉइंट होते हैं वो फिक्स पॉइंट होते हैं एफ एन के, एंड एट द सेम टाइम दे आर नॉट द फिक्स पॉइंट्स of any of the lower composition. For all k strictly greater than 0, that means greater than equal to 1 and less than n या less than equal to n minus 1. तो इनके लिए जो composition functions बनते हैं f के, उनका ये फिक्स पॉइंट नहीं होना चाहिए x. All right, and one can easily observe ओके, सिमिलरली वन थिंग फर्स्ट, दिस थिंग, जैसे हमने फिक्स एफ डिफाइन किया उसी वे में वी हैव पी पीरियोडिक एफ विच इज द सेट ऑफ ऑल एक्स इन कैपिटल एक्स, यू नो, मतलब सारे सेट ऑफ ऑल पीरियोडिक पॉइंट्स हो जाएंगे सच दैट एफ एन ऑफ एक्स एक्स के बराबर हो जाए और एफ के ऑफ एक्स इज नॉट इक्वल टू एक्स फॉर के lying between 0 and n. All right. Now, one can actually easily observe that this set of all periodic points is actually the union of fix fn where n belong to natural number. All right. Okay. अब हम कुछ एग्जाम्पल्स देखते हैं फटाफट से. विल नॉट स्पेंड मच टाइम ऑन दिस क्योंकि ये बहुत ट्रिवियल एग्जाम्पल्स है एंड वन कैन ईजिली डू दिस. ओके, so first of all let us take the first example. So we are considering the dynamical system to be R, topological space associated with F, self map from R to R, which is defined as f of x equal to 2x. That is the dilation map. Okay, so one can easily find out fix f. Take some time. क्या हो जाएगा? Such that 2x equal to x, what you will do? f of x को x के बराबर पुट कर देंगे. 2x is equal to x implies x is 0, implies, so we got our fixed point, so that is 0. Similarly, for periodic point we need to have a look at what is fn x. So it is actually 2 raised to the power of nx. ये आप देख सकते हो. What will be f2x? It will be f composition fx. Okay, so f applied on 2x. Now what it will be? So it is 2 times 2x and that is 2 square x. So similarly fn x is 2 raised to the power of nx, and if I put it equal to x, what I get is 2 raised to the power of n minus 1 into x is equal to 0. और क्योंकि ये term is non-zero which forces x equal to 0, so x equal to 0 आप समझ सकते हैं एक fixed point बनेगा fn का, but it will be a fixed point of all fn, है ना, for all n belong to natural number. So ये periodic point तो होगा. पीरियोडिक पॉइंट, हर एक फिक्स पॉइंट जो भी फंक्शन का होगा वो पीरियोडिक पॉइंट तो बनता ही है, बस उसका जो प्राइम पीरियड है वो डिफरेंट हो सकता है. सो इट विल बी अ पीरियोडिक पॉइंट ऑफ प्राइम पीरियड. आई विल लाइक pd. ओके, आई विल राइट pd. सो इट इज प्राइम पीरियड 1. तो इसके पीरियोडिक पॉइंट में वी हैव ओनली 0. ऑल राइट, नाउ लेट अस हैव a look at one more example, and that is R F. This is the dynamical system where F is a self map which is actually a translation x plus 2. So you can easily check its fix F. Fixed point will be 5, नॉट 0, क्योंकि जो हम एफ ऑफ एक्स को एक्स के बराबर पुट करते हैं यहाँ पे, ठीक है. सो इफ आई पुट एफ ऑफ एक्स इक्वल टू एक्स, आई गेट एक्स प्लस 2 इक्वल टू एक्स implies 0 equal to 2, and that is not true. यानी कि for any x these two quantities will never be equal. Okay, so इसका मतलब there is no fixed point, and fixed point ही नहीं है तो periodic point भी नहीं होगा. That will be 5. Okay, next is R with respect to a self map which is equal to h of x equal to x square. Okay, so here you can easily check that its fixed h will be 2.01, because if I put x square equal to x, I will get 0 1 to be the 2 points, and periodic h, if you will have a look at this, it will be again these 2 points 0 1. And okay, let me write over here only. The last example is the space close 0 1 with a self map, say f, such that I define f from close interval 0 1 to close interval 0 1 such that f of x equal to 1 minus x. Then this is basically continuous clearly. Now if you want to find the fixed f, so you need to put it equal to x. So f of x equal to x implies 2x is 1 implies x is half. So इसके fixed point होंगे just singleton half. And if you will have a look at the periodic point, so for that I need to find what is fnx. Okay, so you can easily find out what will be f2x. First have a look at f2x. Okay, f2x is f composed with fx 1 minus x. Now what you will do, you will replace x with 1 minus x. That gives you x, identity map. Okay, आइडेंटिटी मैप के फिक्स पॉइंट्स क्या होंगे? होल क्लोज इंटरवल 0, 1 will be the fixed point of f2, right? अब मुझे बताओ कि पीरियोडिक पॉइंट्स क्या होंगे. ओके, सोचो जरा. देखो, हाफ फिक्स पॉइंट था f का, यानी कि f1 का. सो हाफ पीरियोडिक पॉइंट होगा ऑफ प्राइम पीरियड 1 का. अब क्योंकि हाफ फिक्स पॉइंट है f1 का, तो वो पीरियोडिक पॉइंट ऑफ प्राइम पीरियड 2 तो हो नहीं सकता, क्योंकि अगर वो एक पीरियोडिक पॉइंट ऑफ प्राइम पीरियड 2 होता तो उसे उसके नीचे वाले का फिक्स पॉइंट होने का हक नहीं होता, राइट? सो व्हाट वी विल हैव, all other points except for this point, they are periodic points of prime period 2. Okay, or set of all these periodic points. Okay, set of all these periodic points close 0 1 हो जाएगा. ठीक है, सो हियर यहाँ पे हमारे एग्जाम्पल्स खत्म होते हैं, एंड वी कैन फाइनली मूव ऑन टू द वेरी इंपॉर्टेंट concept, and that is of topological conjugates. ओके, जैसे कि एज वी ऑल नो, क्योंकि हमने टोपोलॉजी पढ़ा है, हमें पता है कि अगर हमारे पास दो स्पेसेस होते हैं x और y, ठीक है, दो स्पेसेस विच आई एम कंसिडरिंग टू बी टोपोलॉजिकल स्पेसेस, तो अगर वो दोनों आपस में होम्योमॉर्फिक हो, यानी कि अगर उन दोनों के बीच में एक होम्योमॉर्फिज्म एग्जिस्ट करे, तो जो भी एक की प्रॉपर्टीज होंगी वो कॉपी होंगी दूसरे की प्रॉपर्टीज में, है ना। जो भी, अगर एक कनेक्टेड होगा दूसरा कनेक्टेड होगा, एक कॉम्पैक्ट होगा दूसरा कॉम्पैक्ट होगा, ठीक है। और इसे हम बोलते हैं टोपोलॉजिकल प्रॉपर्टीज विच आर प्रिजर्व्ड अंडर अ होम्योमॉर्फिज्म। उसी तरीके से akin to this concept, ठीक है, इन अ सिमिलर वे हम बेसिकली इसी से एक सिमिलर कॉन्सेप्ट चाहते थे, ठीक है। एक सिमिलर कॉन्सेप्ट चाहते थे हम, सच दैट जब मैं दो डायनामिकल सिस्टम्स की बात करूं जो कि आपस में टोपोलॉजिकल कॉन्जुगेट हों, ठीक है, मतलब आई बेसिकली नीडेड अ रिलेशन बिटवीन टू सच दैट अगर एक डायनामिकल सिस्टम की कोई प्रॉपर्टी है तो वो दूसरे की भी वही प्रॉपर्टी हो, ठीक है, तो दोनों की प्रॉपर्टीज प्रिजर्व्ड हो, बेसिकली दैट आई वांटेड, ओके। और ऐसी प्रॉपर्टीज को हम यहाँ पे कहते हैं डायनामिकल प्रॉपर्टीज। अब डायनामिकल सिस्टम की क्या प्रॉपर्टीज हुई, इससे मेरा क्या मतलब हुआ, है ना, दिमाग में आ रहा होगा। सो डायनामिकल सिस्टम की क्वालिटेटिव प्रॉपर्टीज प्रिजर्व्ड हो, ऐसा मैं चाहती हूँ, क्वालिटेटिव प्रॉपर्टीज, क्योंकि होल कॉन्सेप्ट जो है डायनामिकल सिस्टम का इन्हीं पे बना है। ओ, क्वालिटेटिव प्रॉपर्टीज, ओके। मतलब क्या हुआ, यानी कि अगर एक सिस्टम स्टेबल है तो दूसरा स्टेबल हो, अगर एक सिस्टम में क्योस है तो दूसरे में हो, दोनों के पीरियोडिक पॉइंट्स, अभी आप देखोगे अगर दो डायनामिकल सिस्टम्स आपस में टोपोलॉजिकली कॉन्जुगेट होते हैं तो उनके जो पीरियोडिक पॉइंट्स होते हैं, ठीक है, उनकी कार्डिनैलिटी सेम होती है। तो कुछ ऐसी क्वालिटेटिव प्रॉपर्टीज प्रिजर्व्ड रहे, आई नीडेड such a concept, and that was given by this topological conjugacy. And what does it says? So let us suppose we have two dynamical system, say xf एंड वाई जी। आपको अब पता है एफ यहाँ पे एक सेल्फ मैप है फ्रॉम एक्स टू एक्स, जी यहाँ पे एक सेल्फ मैप कंटिन्यूअस फ्रॉम वाई टू वाई, ठीक है। सो टू डायनामिकल सिस्टम्स आर said to be topologically conjugate if there exists a homeomorphism H from X to Y such that H composition F is equal to J composition H, that is the following diagram commutes. Okay, which diagram? So here we have a map, self map from X to X. We have a self map from Y to Y. Okay, so let me write it like this. We have a map from X to X, F. We have a map from Y to Y, G. We have a homeomorphism from X to Y, H. Homeomorphism H, such that this map from X to Y, which is actually H composition F, this map from X to Y equal to this map from X to Y, which is G composed H. ऑल राइट, ये रिलेशन बहुत इंपॉर्टेंट है, वेरी वेरी इंपॉर्टेंट, याद रखना. सो बेसिकली मैं कहूँगी कि दो डायनामिकल सिस्टम्स, ठीक है, टू डायनामिकल सिस्टम्स एक्स एफ and YG, they are, this is the way I write, topologically conjugate to each other. Okay, if there exists a homeomorphism H, okay, from one topological space to the other topological space, such that what happens, such that H composition F is G composition H. H composition F is G composition H, or in other words, this diagram commutes. All right. Okay. Now, this I will show that this topological conjugacy is an equivalence relation. Okay. So this is a remark. The relation of being topologically conjugate is an equivalence relation. Okay, so basically whenever we have a equivalence relation, आपको पता होगा that it basically partitions the set into disjoint equivalence classes, right? And hence this is the only reason we always look for such kind of relations. Okay, तो यहाँ पे हम देखेंगे that this relation is reflexive, that every element is related to itself. So if I have a dynamical system, then it is always topologically conjugate to itself. Okay, and the homeomorphism which does this is the identity homeomorphism. So basically we need a homeomorphism from one topological space to other topological space. So that is this homeomorphism where X is mapped to X. तो इसके लिए हमें एक रिलेशन चाहिए होता था ना, सच दैट द डायग्राम कम्यूट्स, एंड फॉर दैट आई नीड दैट इफ दिस इज H, so ID composition F must be equal to F composition ID. ID is the identity map and that holds true. Okay, that we know. Next is symmetric. This relation is symmetric, means that if you have two dynamical systems, say XF, topologically conjugate to say YG. So back in mind, I have, I should not write since. Back in mind, I have this thing that your H composition F is equal to G composition H. Then I need to show that YG is topologically conjugate to XF, and you can easily show this that it holds true because of homeomorphism H inverse. You know, if H is a homeomorphism, its inverse is also a homeomorphism. So because of that reason, okay, अगर मुझे यहाँ पे show करना हो, obviously H inverse के लिए I need to show that the diagram commutes. So basically मैं बस ये relation दिखाती हूँ. So I need to show कि H inverse composition G is F composition H inverse. ठीक है, मुझे ये दिखाना होगा. Now, how it follows up? So let's have a look at this. Let me change the color. Now, since H composition F is G composition H, if I pre-operate it by H inverse, and also post operate it with H inverse, So what I get is H inverse composition, H inverse is identity. So here I get F composition H inverse, and here I get H inverse composition G using the associative property of composition. I get this thing. Okay, यही मुझे required था. Now I need to prove the transitivity. Okay, final part, final step is transitivity. What does it says? One minute. Yes. So it says that if I have XF topologically conjugate to say YG and H makes it, say H1 makes it, and YG topologically conjugate to say another space Z phi and H2 makes it topological conjugate, then I need to show that XF is topologically conjugate to Z phi. It is an easy task to show that the maps which does so is, okay, so basically we need a map from X to Z, right? And that map will be H2 composed H1, because from X to Y we'll have H1, and from Y to Z homeomorphism will have H2, and composition of two homeomorphism is again a homeomorphism. So this is H2 composition with H1, right? Now one thing, हाँ, okay, हाँ, यहाँ पे हमें दिखाना होगा कि यहाँ पे हमें डायग्राम कम्यूट्स वाला argument भी देना होगा. So here we need to show H2 composition H1 composed with F is phi composition H2 composition with H1. We need to justify why this holds. Okay. So from this and this we have H1 composition F is G composition H1, H2 composition G is phi composition H2. Well, first let us take the left hand side part. So we have H2 composition H1 composed with F. So we have H1 composition F is G composition H1, and H2 composition G is phi composition H2. Okay, so I'm ending up getting this phi composition H2 composition H1 from the left side. All right, and I needed this only. It is equal to my RHS. So I have justified this thing. All right. Now I have three important properties. जैसे कि मैंने आपको अभी when I was explaining the concept of topological conjugacy, तब मैंने बताया था कि ये वो कॉन्सेप्ट है जो डायनेमिकल सिस्टम्स के अंदर काफ़ी सारी प्रॉपर्टीज़ को प्रिजर्व करता है, काफ़ी सारी क्वालिटेटिव प्रॉपर्टीज़ को, ठीक है. और जिसमें मैंने आपको बताया था दैट आई विल बी शोइंग कि उसमें फिक्स्ड दोनों डायनेमिकल सिस्टम्स में फिक्स्ड पॉइंट्स की कार्डिनलिटी सेम होती है, पीरियोडिक पॉइंट्स की कार्डिनलिटी सेम होती है. सो अभी वील बी टेकिंग अप दीज 3 रिजल्ट्स. ओके, बहुत इंपॉर्टेंट रिजल्ट्स हैं. So let us have a look at them one by one. First is now if XF is topologically conjugate to YG dynamical system. So that means if two dynamical systems are topologically conjugate, then XFN is also topologically conjugate with YGN, where Fn, it is the composition of F with F n number of times. This is the composition of G with G n number of times. And क्योंकि F एक self map है, तो Fn will be again a self map. It will be a map from X to X. And because F was continuous, so Fn will also be continuous. And similar arguments goes for G as well. Now, we need to show that they both are topologically conjugate, and this holds for every n belonging to natural number. All right. So, first of all, we will justify this. Okay, so basically इसमें हम क्या यूज करने वाले हैं, प्रिंसिपल ऑफ मैथमेटिकल इंडक्शन. जहाँ भी हमें फॉर एवरी n के लिए प्रूव करना होता है, वी यूज PMI. So here clearly the result holds for n equal to 1, क्योंकि हमें गिवन है कि XF is topologically conjugate to YG with a homeomorphism H. Now for n equal to k, let the result holds true. So हम मान लेते हैं कि n equal to k के लिए ये सही है. For n equal to k plus 1, we will prove the result. Okay. So for n equal to k, if the result holds true, so back in my mind, I have that commute wala relation. Okay. That is H composed Fk is Gk composed with H. Okay. And यहाँ पे क्योंकि ये भी topological conjugate है, so H composition F is G composition H. Why I'm writing this? Because I'll be taking help of this. So let us start with H composition Fk plus 1. हमें दिखाना क्या है? हमें यही तो दिखाना होगा कि वो relation hold करे. इसके लिए basically what do I need? I need this H composition Fn. H composition Fn is equal to Gn composition H. Okay. So let us have a look. So let us see. I can write it as H composition Fk composed with F. Now what is H composition Fk? It is Gk composed with H composed with F. Okay. So this is from 2. Let us mark it as 2. Let us mark it as 1. All right. Now, this is associative. Composition is associative. So I can write H composition F. Now, using 1, H composition F is G composition H. Now, again, using the associativity. So, finally, we have this is G K plus 1 composed with H. And this is what I needed for K plus 1. So hence, now basically I can conclude that, therefore, what I have, that XFN is topologically conjugate to YGN for all n belong to natural number. ठीक है, यानी कि हमने अभी just क्या prove किया? We have proved that if you have one dynamical system and it is topologically conjugate to another dynamical system, and H is homeomorphism between the two spaces, topological spaces from X to Y, which is मतलब जो इसको enable कर रहा है, H is that homeomorphism for this. That means H composition F is is G composition H, then it will also work if you take the self map to be Fn. They will also be topologically conjugate. If you take the self map in place of this F, if you take Fn in place of G, if you take Gn, then again they will be topologically conjugate. So this we have proved. All right. Now let us take the second result, okay, which says that if we have dynamical systems which are topologically conjugate to each other, then it implies that cardinality of fixed F is equal to cardinality of fixed T. Basically, what we will show over here is that if X is a fixed point of F, not if, this is equivalent. So X will be a fixed point of F if and only if H of X is a fixed point of G. Okay, we will show this. Let's start. Okay, let me take this some nice color. Okay, so X belong to fixed F if and only if F of X equal to X, if and only if we can apply H, right? H एक homeomorphism है, so it is a bijective map, so it is 1 1. So if 2 points 1 1, or we can say basically well defined है, so if X equal to Y, Hx is equal to H of Y. All right, next, so we have H composition Fx equal to Hx. Now what is H composition F? We know it is G composition Hx, so that is equal to Hx, right? And that is if and only if this Hx is a fixed point of G. So we have finally proved that X is a fixed point. X is a fixed point of F if and only if X is a fixed point of G. Okay, and that is what we needed. So इसी से we have this implication, क्योंकि एक इधर फिक्स पॉइंट हमें तभी मिलेगा जब इधर h of x फिक्स पॉइंट होगा g का, तो कार्डिनैलिटी जो होगी दोनों की सेम रहेगी. यानी कि अगर दो डायनामिकल सिस्टम्स आपस में टोपोलॉजिकली कॉन्जुगेट होते हैं तो दोनों के फिक्स पॉइंट की कार्डिनैलिटी सेम होती है. वेरी इंपॉर्टेंट रिजल्ट. सिमिलरली लेट्स हैव अ लुक at third result, which says that if two dynamical systems are topologically conjugate to each other, then they both have same number of periodic points. जैसा कि मैंने topological conjugacy समझाते हुए बताया था. Okay, let's prove this. So basically what we will show that X is a not this, I will show we will show that X is a periodic point of F of prime period n if and only if h of x is a periodic point of g of prime period n. अगर एक x इन कैपिटल x पीरियोडिक पॉइंट बन रहा है f का ऑफ प्राइम पीरियड n, तो h of x जो होगा, and that is if and only if h of x will become periodic point of g of prime period n. So let us try to prove this. Now let करो x belong to capital X be periodic point of f of prime period n. Okay, so that is fn x is equal to x the way we define, and it is not a fixed point of any of its lower composition for all k strictly lesser than n. So that is if and only if h composition fn x is equal to hx and h composition fk of x is not equal to hx for all k lying between 0 and n. Now h is basically a homeomorphism from x to y. Okay, so if I have 2 points which are not equal to each other, तो उन दोनों की जो इमेजेस होंगी है ना, वो भी डिस्टिंक्ट होंगी क्योंकि h 1 1 है. It is bijective being a homeomorphism. All right, so we have this thing. Okay, so this is if and only if. Now you know, क्योंकि अगर एक्स एफ वाई जी आपस में टोपोलॉजिकली कॉन्जुगेट होते हैं तो एक्स एफ एन और वाई जी एन भी आपस में टोपोलॉजिकली कॉन्जुगेट होते हैं. सो फ्रॉम दैट वी हैव H composition Fn. H composition Fn is equal to Gn composition H. So we can write Gn Hx is equal to Hx, and similarly Gk Hx is not equal to Hx for all k lying between 0 and n. And that is if and only if, which shows h of x is a periodic point of h of prime period n. Because it is a, क्योंकि मैं यहाँ पे देख पा रही हूँ hx is a fixed point of gn, but hx is not a fixed point of any of its lower composition, right? So means it is a periodic point of prime period n. So this is what I have. Okay, so therefore this suffices to show that we have, if we have two dynamical systems which are topologically conjugate, then they have same number of periodic points. All right, so here we end this lecture. Hope you liked it.